Kalimera, good morning everybody. I'm Petros Koumoutsakos. I have the pleasure of chairing the panel on AI and entrepreneurship. I am joined today by distinguished guests, and one guest that we hope that will join us later. But let me start by saying, introducing myself actually, the people who are in the panel. On my left is Eleni Haji. She's a professor at ETH Zürich. She's working structural monitoring, digital twins, and she's doing a lot of exciting work on AI. We have Aristos Doxiadis, who, among many other things, he's also working at the Big Pi Ventures. I always use Pi as my initial too, so I appreciate that. Mine, Pi, is smaller than yours. So anyway, so he is doing a lot of work on venture capital, economics, and policy. He has been writing a lot of great articles about data, how one can use them, how can data enable AI in our times. So we're very excited to have you. Then we have Ioannis Emiris. Emiris, I know Ioannis from a long, long time ago from Berkeley. And Ioannis, he's the president or chairman of one of the most prominent research centers in Greece, the Athena Research Center, but he's also has been working himself on algorithms, and today he's working on algorithm and in building research ecosystems. Then we have Ioannis Kevrekidis. Ioannis Kevrekidis, he is a professor at Johns Hopkins University. He's also a program manager at DARPA, but I would like to say one more thing about Ioannis. Ioannis is probably the first Greek scientist who had the idea of using AI to solve complex problems. He's one of the he's the pioneer of AI for complex systems, and I would like to acknowledge that because not many people know about your contributions. Then we have Kostas Mallios. Kostas has been working in different capacities in different companies like we know probably, like Microsoft, companies that we don't know, but they're as important as intellectual ventures. And he's actually working today as a chief executive officer or technical officer. I'm sorry, I remember the
corporate vice president.
Corporate vice president. Sorry, you just got a promotion. No. At Applied Materials, he has seen AI in different capacities and in different how it's enabling industry and how AI has been working in the real world. So we are very excited to have you and to hear your insights about innovation and strategy. And finally, the person that is missing is Pushmeet Kohli, who is the... we're not missing Pushmeet. Hi, Pushmeet. Just in time. Can you hear us well?
Yes, I can hear you well.
So if I would say that you are the head of AI for science at DeepMind, and you're joining us from London, and we very much look forward to host you in Greece next time.
Awesome. Yes, absolutely. I'm really sorry I couldn't sort of join the panel in person, but definitely next time.
Super. So I had a chance of sending a questionnaire to the panelists, and then I looked at this questionnaire and I didn't like it, so I'm going to change it. And so I'm not completely, but not completely. So no worries. So I have a question for all of you to start the panel. So the question that I have, and if possible, make it about AI entrepreneurship. What are you most excited about these days? And I would like to start maybe by Ioannis Emiris, who's sitting in the middle of the panel.
Thanks for the hard question, and thanks for the invitation. Most excited, the young people I saw yesterday at Athena. It was a very dynamic crowd. It concentrates people that I've seen a similar atmosphere in the past in the best conferences, let's say, in computer science. Today, best minds, young minds, are attracted by this model. I don't know if it's the best model that exists for economic expansion, but it's the current model. It's very optimistic that our students, our researchers, are attracted and are able to create value and to make their ideas sustainable. Someone mentioned it this morning, I think the BCG group, that the important thing is to not to earn money, but to have an idea that has traction. And we see people even before finishing their studies that get into something important. Mm-hmm. Now, because we are today, many times this is related to AI. Not necessarily, but very often AI related.
Okay, super. Thank you very much. Kosta.
I'm pretty excited by the disruption that's happening. Every time there's a disruption, there are opportunities for young people, for older people, for everybody. And I think when you look at the existing companies, the existing economic mix, it's a great opportunity to look at it as something that's probably going to be gone in 20 years. And that means all opportunity for the existing companies if they're vigilant, and great opportunity for the younger generation to build something new, build something better.
Okay, thank you. Aristos.
I'd say I'm excited about three things very briefly. The first is excited in, let's say, the negative sense, is that nobody really knows what the technology is going to look like in 10 years. We all have assumptions, things are happening, but it's extremely fluid. We don't really know, and it's the first time I remember where we've been in this position. The other thing excited in the positive sense is we see a shift of skills. People who are very able, very capable, and so on, have to think hard about how they will be using the new tools, even as the new tools are not fully formed yet, and have to shift, let's say, from people who code, for example. I saw there's a new startup called Cursor AI, which has done extremely well in the past year, where they say that we will not be dealing with people who write code anymore, but with what they call logic designers. So people have to forget about writing code and have to start thinking about the logical building blocks of new models. So this is a second thing, the huge change in skills that we need. And the third thing I'm excited about is what I see is happening in the physical world, for example, in agriculture with AI, and how things can change very, very quickly in the productivity of agriculture, in having clean agriculture, et cetera, et cetera. So I'm very excited about that as well.
Thank you. Eleni.
I don't know if there's much to add. I mean, I'm excited about engaging indeed different fields and the younger generations, and I'm really excited from the research point of view on the potential that now exists for discovery. I mean, discovery that is opened up and transcends boundaries. I'm very excited to be using methods that maybe are developed originally in vision and in the domain of speech, and then putting them into use for engineering structures, for health, and so forth. So it really, there is really no boundary, and this is what I think is truly amazing currently.
Thank you. Yanni.
It is both exciting and negatively exciting, as you said. It is scary. You may remember a long time ago there was a Greek song that said «Φοβάμαι όλα αυτά που θα γίνουν για μένα χωρίς εμένα». I'm afraid of all of these things that will happen to me without me. But if you ask me about excitement, really, as Eleni said, it's new paths for creativity. And having Pushmeet here, let me say that on February 19th, there was an announcement on which he was a co-author about an AI co-scientist. That's one of the examples of co-scientists that are coming up now. And it is really interesting to try and think of how we use them, and then how we teach our students to use them, and how they are going to develop. They are coming up. You know, there was a wonderful saying, Janos Bolyai was one of the first people that considered non-Euclidean geometries, and his dad was a student of Euler. And he was suffering trying to write the best version of his paper, and his father said, don't worry about it being perfect, publish it. When the right time comes, ideas are springing up everywhere like violets in the spring. I think we are in a time at which the same ideas are coming up everywhere like violets in the spring. And this idea of how to have the human AI interaction, maybe in the form of a co-scientist, is the thing that seems to me both extremely exciting, extremely liberating, and quite scary.
Thank you. Pushmeet, I think this is the right segue to you. Maybe you can tell us beyond co-scientist.
Yeah, so I think it is a very exciting sort of time. It's an amazing time. I mean, if we look back at what has happened with the internet, I mean, the people who grew up like me without the internet, and then we saw how the internet sort of changed the world. I mean, can now see some similarities. I mean, the internet really democratized information and knowledge. And what we are seeing now is AI beginning to sort of democratize and make expertise and intelligence really abundant. Now, this is both in the form of sort of democratizing existing expertise, but also going beyond human expertise today and pushing the boundaries of science, coming up with completely new ways of thinking about problems. If you take examples of AlphaFold, that was a system for predicting the structure of proteins. Some things that took sort of from a year to 5 years to do for a single protein. And now in the matter of, and took $1 million almost in many cases. And now you can do it in a second for a few cents. That kind of transformation, that superhuman capability is going to transform many different sort of domains. And then sort of these powerful tools will allow us to now sort of think about many different problems in a completely different way. And I think the only limit is the limit to our imagination as to how we use these tools for the benefit of humanity. And I think that's where the challenge sort of lies. How does Greece has been the cradle of democracy, so in some sense we are in a very appropriate place to think about what is the new system of governance, what is the new system of utilizing, and what is the right philosophical ways in which we will govern the interactions of these very powerful tools with how humanity sort of uses them for the most important problems that we want to solve.
Thank you. So what is unique about this panel is that we have people who have been working with frontier research, and at the same time, they have been looking into the deployment of this frontier research into the real world. So I wanted to ask, first question, perhaps I'll stay with you, Pushmeet, if you don't mind. I wanted to ask, how do you decide which one of the research that you do at DeepMind, how do you decide which research is ready to become a product or a company? What are the features that frontier research needs to have in order to become a product or a company?
Yeah, so one of the things that we sort of are really focused on is looking at being problem focused, really thinking about what is the problem being solved. Sometimes there is a tendency that we say we have a very powerful hammer and then let's look for nails. And that kind of thinking could work. But in many times, the most transformative, paradigm-changing things happen when you really think about what is the underlying problem that you want to solve. And in our case, like if I would give the example of protein folding and AlphaFold, we started this project in 2017, 2018, and we have been working on it for the last sort of 7-8 years. And like in some sense, we were not experts. When we started off, we were not experts in structural biology. But what we sort of discovered as part of our due diligence is that this fundamental problem is a root node problem that will not only unlock one small application, it brings about a whole paradigm change in an industry, whether it's pharmaceuticals and drug discovery or synthetic biology or sort of material science. It really is a core capability. If you can really understand proteins, like it will have a transformative effect. So at DeepMind, we really focus on these root node problems, and then we worked on that for many years. Like AlphaFold 2, which was the breakthrough, came after sort of 3 years in 2020, like in the height of the pandemic. We released it in 2021, and now in in 2022, we started sort of working on isomorphic labs, which essentially spun off this technology for accelerating drug discovery with a very sort of focused mission of drug discovery, while we are still continuing to sort of expand and use this technology for many different applications. So, in terms of what is the right time at which the technology becomes useful, like you have to really understand the domain. We sort of from the very get-go, we worked with people who were working on the ground, looking at how are they trying to solve the problems that are important today, and why is this thing a critical step. And I think you need to sort of get those people within the whole project loop from the get-go, and not just at the start, but through the whole sort of process of the project, right? You want to understand what is the impact the technology is going to have in the application, and only when, and in our view, basically, our particular sort of aim is to bring about to work on technologies which will have a paradigm shift, right? We can do incremental work as well, but I think where we are uniquely positioned as a research organization, which can invest a lot in longer time scales, we have a unique position, and in fact, I think also a responsibility to work on the most transformative, paradigm-changing things that maybe other entities are not able to invest in for those longer-term horizons.
Thank you. Yanni, Emiri, if I may ask a similar question. How do you work on this domain at Athena? How do you take innovations that are happening at the Athena Research Center, and how do you accelerate the deployment of these innovations into the market?
Okay, there's many parameters. Let me focus on the most important ones, or some characteristics that are relevant to research centers, maybe universities as well. I think the most critical point for us is to convince the researcher to let the baby go, and to convince them to collaborate with a business guy. Yeah. Very often they don't recognize the need, or they would think that the business aspect will change the nature of their invention, which is very often true. We are lucky to have in the table the man that helped Athena bring InnoEthics to the market. Athena has a very big success story, I have to say to the audience. When we sold our startup to Samsung 5 years ago, 6 years ago, on text-to-speech, speech-to-text, it's still the biggest exit from the academic ecosystem. It was, if I can comment on that experience, it was a very difficult task for Athena. It went through the valley of death, whatever. At the same time, there were other efforts, other groups competing for the resources within Athena Research Center. So we had to take some painful decisions. The outcome was very successful. As we all know, today, the R&D of Samsung in Greece is basically our team. And to put one more aspect there, is that the research center has to think of what is losing in this game. We lost a group because that work, the technology, the expertise moved to the industry. But this is our mission. So that's some of the, I guess, some of the important features in the game we play every day.
So I presume you're referring to Kostas for this person?
Kostas,
yes. So I would like to go to Kostas and ask him, what did you see in this project? Or what are you looking in frontier research when you decide, yes, this is something that I would like to follow up and try to bring it to the market?
InnoEthics, I think, was for me, one of the great success stories of government-funded research. And Athena, and I believe it's, at least at the time, it was the only exit that the Greek state had a stake in, 10%, if I remember correctly, when we sold it to Samsung. I love what you said. You weren't there at the time. You're now, the new director, but your assessment is absolutely spot on, which is there was a team that was laboring on this technology for 8 years. We sold it within 8 months, 7 or 8 months to Samsung. The other night, I have a friend from Qualcomm in the audience. Qualcomm, the chief scientist of Microsoft Research based in Israel, and I, and Emilio, who is now currently still the head of the Samsung R&D effort, had dinner in Alimo, and we were talking about AI. That, to me, was the success, where you had a group of very dedicated researchers that came together, saw the advantage of actually selling to a big multinational corporation, is now playing on a world stage, and that, I think, gives a model for new research, for new teams, I think, to look at and say, it can be done. You know, the research can see the light of day in a commercial application. And not just that, but I think this team specifically in Greece has been voted the best software acquisition in Samsung worldwide, I think twice, as far as I know, because I'm still very much in touch with the team. So I could just say there are success stories that I think are important for us to create that will allow others to emulate, to learn from, to discard. But I think these success stories are really important.
Thank you. Aristos, if I may come to you, maybe stay a little bit on the same theme. I wonder if you see particular, how do you assess when you have a new company that's coming to you, and how do you assess the long-term viability or the scalability of a particular company? And in particular, as Ioannis Kevrekidis said earlier, like this, and Ioannis Emiris actually said that we don't know where we're going in 10 years. So this long-term viability and the scalability, how do you go about it?
Okay, as I said earlier, it's difficult, especially in this environment, to know what the competition will be like in 10 years or what new products may come and suddenly disrupt what you have been doing and so on. Having said that, I think the most, first, of course, they need to have good engineering and good science. This is the first thing. But beyond that, they need to know how users work in a specific domain. And to know that the users will see the value of their solution. Sometimes you design things in a startup where it's obvious to you that it has huge value to a doctor, for example, but you've never spoken with doctors that you hope will be using it. You need to understand how doctors or whoever else your user base is going to be think and whether they will see the value and adopt it. So it's important for startup founders, especially in deep tech, to go and speak early with what are known as KOLs, key opinion leaders. In the case of medicine, for example, if you're doing something for, I don't know, in kidney transplants, you have to work with kidney surgeons, kidney specialists. So you need to find the best, not only in your country, but across America and Europe, and speak to them early and saying, if I give this device to you, will you use it? Do you want to use it? And you will hear a lot of things that you never anticipated. Once you get KOLs on board and have some good institutions using your technology, then you have a better chance of pushing back against new competitors, because humans are much more inert than technologies. Technologies change very fast, but humans in their everyday practice change much slower. So once you get a group of people who have adopted your solution, then you have a good chance of selling your solution for several more years, even if it may not be cutting edge for after some time. And the other thing that is important in the context of AI is knowing the best and most relevant data sources that you will use for your model and your algorithm. And I'm not talking here about LLMs, which use data sources from the internet. I'm talking about specific things that some domains may need. I'm talking about, for example, if you do maritime signals for the speed or the orientation of ships, this type of data source, you have to think exactly what would be the best type that you can use so that you can produce the solution. So I would think these two things would make, in my view as an investor, a potential startup sort of viable. I'm always saying sort of viable and sort of scalable because, as I say, we are in an environment of great uncertainty.
Thank you. So since the topic of data scarcity came up, I'd like to turn to Eleni Hadji, that I know she's doing a lot of things with data and uncertainty quantification and things like that. And I know that you're working in a domain which is structural health monitoring, which is in a traditionally conservative sector like civil engineering. So you have a lot of things piling up in front of you. The sector being conservative, but among all these things, how do you deal with data scarcity? And for this, I would like to hear also both your entrepreneurial or industrial expertise as well as your scientific expertise, because I know you work on this topic.
Yeah, this is true. In my domain, we have a lot to do with problems from actual practice and with authorities often, where a lot of opportunity exists to make a change. But the uptake is often slow. Usually these operators and owners, they prefer to have solutions that are certified. And this means that maybe sometimes are incremental. And so for us, it's very important to have the possibility to convince them. And in our case, we actually convince them usually by explaining that data alone is not enough. So we try to bring physics in the loop. We try to capitalize on the engineering knowledge, which is also fundamental knowledge for these experts that are really the operating experts in the application domain. And through this synergy, we try to deliver solutions that are actually interpretable or explainable. And these are the kinds of solutions that they can then develop trust on. And then we also count on the ecosystem in our university, for example. This creates the opportunity for innovation through training, through appropriate funds and coaching opportunities. And with all of this together, it is possible to create a culture of innovation that allows to make a jump, a leap with confidence. So it's somehow a balance between what you can promise as innovation and what you can promise in terms of trust, in my opinion.
And you didn't answer my question about how do you deal with data scarcity in a scientific context? Yeah.
This is where we actually try to bring physics in the loop. We use physics to perform effectively data augmentation. In our kinds of applications, you have structures that are unique. You cannot claim to gather data that are representative of failure from massive, let's say, in massive quantities. And again, in this case, we have to bring our trust back to the fundamentals, to what we know can actually simulate a problem. And even if it cannot, we can use it as some sort of an approximation that can create a type of data set for us, complete with uncertainty, that we then use to complement this missing knowledge. And then we can also do prediction and not just limit ourselves to what is a diagnostic capacity, just outlier detection, where we know purely data-driven methods may excel in, but are simply not enough when you want to go to the prediction task, the forecasting task. There you have to bring some sort of intuition in the loop, what we would call as a positive inductive bias. The fundamentals that we have been taught and still express the world we live in through first principles.
Thank you. So, Yanni, staying a little bit on the physics, but it doesn't have to be physics only. It can be also mathematics and everything else. Where do you see the relationship between these fields? How do these fields evolve and the presence of AI? We see there's great advances on AI in forecasting the weather, on developing new proteins, new materials, and also there is mathematics AI is making inroads in mathematics as well. There are a lot of new great achievements. Where do you see the relationship of AI and the different application domains?
Is everything in the world?
Yes,
Yes,
including uncertainty.
Including uncertainty. I will say some platitudes and then maybe some things that are personal opinions. First,
I prefer your personal opinions if you don't mind first.
Okay, so first I will stay with a word that Eleni said, fundamentals. There was a time, I'm a chemical engineer by training. Traditionally, people were taught technology at school, but then there came a trend in which people were taught fundamentals, the idea being that the technology will change, but the fundamentals will be important, and people will always be able to think and apply them to new things. What we do see now is that in addition to the domain fundamentals, we need, as you said, applied math fundamentals and some computer science fundamentals, and then trying to find what of all things we're going to teach people, I'm thinking as a professor of what it is that we're going to teach people, is something extremely fluid at the moment. There are things that are enabling. For example, there is the issue of exploiting AI for a sort of personalized education trajectory for everybody so that people can come more quickly up to speed. But in the terms of, again, going back to Eleni, of uncertainty for very high dimensional problems, I personally think, even with all the correct things you said, uncertainty for high dimensional problems is still open. We still do not know how to do it. It's a frontier. For relatively low dimensional problems, we know how to do it and how to go about it. I have this sense that in the last few years, techniques from machine learning are being, math for high dimensional problems is enabled by machine learning technology, so that one would, for example, try and solve optimal control problems in high dimensions, do differential games in high dimensions. I have some hope that there will be new math techniques for the high dimensional problems, but still uncertainty in large problems is not easily doable. The last thing that I'm going to say, going back to teaching, having also to do a little bit with what you said, were saying before about scarcity of data, is that it made an impression of me looking at a Microsoft blog, which I think was end of April somewhere. It said two things. The first thing is both a university and a new company can buy knowledge on tap these days. And the second was, and it resonated with me as a professor, when you start as a research administrator, as a young professor that have your own research group, you have to somehow learn by practice what it means to manage a research group, who to hire, how to train them. And it seems, and that was in the Microsoft blog, that these days every researcher is a little bit of a group manager of AI agents, so that you have to know which agent you will buy or you will connect with. What do you need to train versus what you will get from them? And this idea of a skill of a grad student, if you want, as a, not a CEO, but as a group leader of AI agents is new. We don't get taught it. We don't yet teach it to our students. And it's interesting that maybe we should consider how this would be best done.
So thank you. I wanted to stay a little bit on this topic of uncertainty, but maybe try to join it with philosophy. And I think there's different types of uncertainty in the Greek philosophy, going back to the Democritian way of defining uncertainty, and then the Epicurean way of defining uncertainty. And actually, I remember myself being in a meeting at the Naval Research Lab with Ioannis sitting next to each other, and I said, Ioannis, have you seen what was the PhD thesis of Karl Marx? And Ioannis says, no, please don't show me this here and now. But Karl Marx actually wrote about these two types of uncertainty in his PhD thesis. So I wanted to turn to Pushmeet and ask, how do you see the soft sciences, like philosophy, ethics, and all these topics, including uncertainty, causality, and ideas of this kind? Do you think that these topics may be of value to artificial intelligence per se, but also artificial intelligence as it is being applied to different topics? Like to hear your thoughts. And also, I think coming from India, you guys have also a philosophy that goes even before ours. So maybe ideas from there can also be welcome.
Yeah, so I think uncertainty lies at the heart of this fundamental sort of question of what is happening around us. Just to ground it in one concrete sort of application, again, like going back to, I'll go back to this example of AlphaFold, because I think it is really pertinent in the case of AlphaFold. AlphaFold, like people sort of see it as a big breakthrough in the ability to do protein structure prediction in terms of its accuracy. But I think that's only partly the breakthrough. Even if it was getting you like perfect accuracy, right? And like a 99% accuracy, although that's not what it gets, it basically gets much lower, but still very useful. Even if it got 99% accuracy, but it did not know which 1% of the problems it got wrong, its use would be much lower, because people wouldn't know which prediction they can trust and which it cannot. So in some sense, the key breakthrough of AlphaFold was not just that it was accurate, but it was also very well calibrated, in the sense that it really understood when it was making a mistake. And its uncertainty predictor, where it said, I'm giving you the structure of this protein, but this part I'm not really sure, was a critical sort of part. Now, going back to sort of epistemic versus esoteric sort of uncertainty, like it happened in the case of a protein structure prediction as well, because what it would say is that for certain proteins, I don't know, like I can't tell you what the prediction is. Like I'm making a prediction, but it's all sort of red, in the sense that I have very low uncertainty, very low sort of certainty about it, low confidence about it. And then scientists later on tried to analyze what was happening with those predictions. And as you would know, like in sometimes like proteins, they are not just rigid objects. They actually move around, and then parts of those proteins can be flexible. So they don't in fact have a structure, and they only have a structure in certain cases, in certain contexts. So some of these disordered regions were being predicted by AlphaFold. So the AlphaFold confidence measure could be used as the state-of-the-art predictor of disorder in proteins. So that just shows you how important the uncertainty sort of predictor for AlphaFold was, like in enabling its use in that particular application. But more broadly, if we step back and look at the AI tools that we are all using, I think Ioannis said a very important thing, that as we are now hiring these sort of individuals who are using these AI sort of tools and AI agents. And I think one of the things that we really have to teach the students around us as well is, how do we understand the uncertainty associated with these predictions? Some of these tools, especially large language models, do not have a very good sense of confidence, or they're not uncertainty calibrated within them, right? In some sense, sometimes they make an amazing argument, but sometimes they just hallucinate, and it's completely wrong, right? And so students at some point in time have to tease out, and this is particularly important in the case of coding. Like Cursor was sort of brought up as an example. If the agent produces code, which is very valuable, and and it really increases developer productivity, but there might be one particular error that if the developer is not able to detect and take out, then that brings about a lot of risk in the overall system. So we really need to make sure, one, that these AI systems are very well calibrated in terms of the uncertainty that is associated with their predictions. And secondly, are the people who are using these systems have a good sense of what is the right solution, and they can judge, and they have a good understanding of the behavior of these systems and how to interpret these confidence measures.
Thank you. So I want to stay a little bit of this on this topic of uncertainty and the evolving landscape of AI, and I would like to ask this question to Kostas, that considering that we have an evolving landscape, an evolving field, and at the same time there is a lot of different types of uncertainties, how do you navigate this field? How do you decide, first of all, yourself about where to fund and what to finance? But also, how do you guide the startups in which you finance and you fund to navigate these very uncertain waters?
Yeah, great question. So two things. There was a comment about fundamentals, which I think is spot on. I think while AI is a new technology, I think the pervasiveness of AI is going to be pretty amazing. You know, we used to say at Microsoft that everything that can be digitized will be digitized. I think we can say today that everything that is digitized will be infused by AI in one way or another, regardless of industry, regardless of vertical, regardless of application, whether it's in the UX layer or, you know, in the middle somewhere or on the back end. You know, agents will be trolling every architecture, creating their own APIs to get data, to, you know, to basically, you know, hunt for value, if you will. But at the same time, while all this is very shiny and very glitzy, you have to pay attention to the fundamentals. The fundamentals are, it's still a product. It still has to generate ROI. It's a technology that will be deployed over years and decades. We're very early in the cycle. It seems like everything's been taken over by AI, but we're very early in the cycle. So companies, whether they're large enterprises like Applied Materials, which enables a lot of the new chips that are coming out, which will run a lot of the new models, et cetera, et cetera. Also for startups, it's something similar. They still have to play and integrate with existing legacy models. So you have to ground yourself in these fundamentals, because you still have to figure out how to interact with legacy systems, you know, because AI are wedge solutions right now. They're not the solution. Even if you're thinking about AI native, it still doesn't encompass everything. So there's a lot there. So the fundamentals still matter.
Thank you. Yanni and Emiris, may I ask you the same question on top of everything else? You're also working with the government, which adds another dimension on uncertainty. So what is your take on this? How do you coordinate all this?
Okay, so let me start with so let's focus on this aspect. Indeed, in Greece, I would say that it's not only the problem of research centers or universities, it's also the problem that maybe the investors will face at some point, because they have to navigate through current law, expected legal reform, and so on. So I would say our biggest problem, which is more general, as I said, than just research institutions, is the instability in the legal framework or the government framework. It's not the bureaucracy is there, it is an issue, but I would say it's an issue in many other countries. I would say what the biggest issue is the changing landscape, is the changing, the lack of stability. Right now we have a prime example with the Recovery Resilience Fund. We have planned a lot of activities, we have planned a lot of infrastructure building. We have a time frame, and we would like that the government keeps their promise. Let me put it like that. We do not expect big improvements or big additions to what has been promised, but we would like things to be executed as planned.
Thank you. So I think another thing that adds to this uncertainty about AI and its deployment and its adoption, we've heard this solution of focusing also on fundamentals. And another issue is there is a lot of value in AI, but there's also a lot of hype in AI. And I would like to ask this question to Aristos, in particular as an investor. What are your criteria for separating value and hype?
I think there's two types of hype that we see most often. One is you get people who have worked on a technology, a technical solution to a problem before AI became so prominent, and then they sort of dress up their old product or their old algorithm with some AI-like features, like chatbots, for example, chatbots. But then there's no real change in the underlying fundamentals of the original product, and this is one type of hype, and you can recognize that, you know, pretty quickly, but you need to look for that. The other type of hype has to do with a more basic problem of the relation between research and actual use value. One can see a lot of teams that have new ideas about new techniques of AI that were developed in their lab, in a research institution. but without having targeted a specific real-world problem while they were developing that. So they end up with what we call a solution looking for a problem. They don't really know who is going to use that or how they could use it. And this is the other type of hype. And this comes into the discussion about fundamentals that we had before. It is important that there is good leading edge technology on the one hand, and that the architecture is based on very solid fundamentals. And this is what good research labs do. But this has to be combined with some sort of idea of what is happening in the real world. So if you ask me what's the most important thing to make fundable something and go by the hike, I come back to something I said earlier. Real world users have to show that they want this and will adopt it. That's it.
Thank you very much. A quick question to Pushmeet. I want to be respectful of your time. I know you had time only at the half after the other. I wonder if you have another 10 minutes to the completion of this panel. Is that okay? Thank you. So I want to go to Ioannis Kevrekidis and ask maybe another angle. You have worked in many different disciplines, and what is wonderful, I find, about AI is that it brings people from different walks of life, and they're working on a common theme of AI, and then this AI is applied to medicine, is applied to engineering, is applied even to law. So I wonder, is this interdisciplinarity something that is worth fostering? Do you let it happen by itself? Do you see value? Also, you mentioned an education that people should have. We always argue about interdisciplinarity. Would you like to elaborate on this topic of AI and interdisciplinarity?
I think, my microphone. So I can, I think this is the third time that something like this happens. The first time, in recent memory, the first was computers in the late 50s and early 60s, when a technology came together that put a lot of people from very different disciplines being able to work together in a new way. The thing that happened in our youth was nonlinear dynamics. There was a time at which a new technology, a new mathematical technology came up, and suddenly people from chemistry and physics and economics and whatever were coming together, digging up their old results, finding a new language for being able to describe what they were doing. And then this is another opportunity. It's quite wonderful that, again, physics and chemists and economists and cognitive scientists and neuroscientists can talk about the same things with the same tools and be able to collaborate in new directions. So I think we don't particularly need to foster it. It springs up by itself, and it has its own life. It is something that takes us together with it. One of the things that, a couple of little other things to say along these lines. First, I like, this is just a stupid personal thing, I like thinking more of small science models like rather than large language models. So having, let's say, foundation models that are built by us, we know what is in there, we know how to design new experiments and so on and so forth. Another thing is everybody, it seems, but for example, very good people like Alan Asper-Guzik, who is a friend, and he is a god in using AI in chemistry. One of the major endeavors these days is using their foundation models and agentic AI models to run a lab in Cambridge or to run a lab create the necessary new data that are required in order to validate or progress a hypothesis. And the last thing that loosely I wanted to say is that for a very long time, I had the impression that getting principles so that you don't know a lot of knowledge, like the Middle Ages, not having a database in your head, getting principles so that you could compactly communicate what you're doing to somebody else, is a very lofty feature of the human mind. When do we understand something? When we can compactly describe it with a few things. I think as time goes on, I start thinking that getting principles, getting compact ideas, generalizable, useful ideas that we can communicate with each other, has much more to do with communication. You're capable of compacting something when you need to communicate it to somebody else, either to teach them to become doctors or in order to get them to help you do something. And I think it will be really interesting, for example, in looking at the communication between agents in material science, to see what they will choose to tell each other and whether they are going to get a different language, maybe better than the one that we have, in order to be able to describe it. So I think the communication, certainly between people and AI, but actually between the AI agents themselves, is something that is really, really interesting these days.
Fantastic. We have scheduled about 10-15 minutes for questions for the audience to the panel. So maybe if people are interested and have questions, please raise your hands. And there is a microphone that is going around to the audience, and then I will repeat the question, and maybe you can allow me the discretion of pointing it to a person in the panel. Do you have any questions? Otherwise, I will continue myself. Please, yeah, thank you.
Thank you for the insightful conversation in the panel. My question is, where do you see Greece around the AI movement? And is there a model that has been developed in Greece that could, let's say, be in the battle between other like GPTs or Gemini or larger?
Okay, so the question is, what is, so you're talking about language models? I'm sorry. So you're talking about language models and how do they pertain to the Greek society ecosystem?
No, I'm talking more about, is there a model in Greece, or LLM model, that's actually comparable to what is happening outside of Greece?
I believe maybe Ioannis Emiris wants to address this.
I can say a couple of things. First of all, I would say that it's important for the companies not to think within local boundaries, of course, and to think big. And Greece is a very small market. Greek industry is not ready to support the scale and the dynamic progress of AI if a company wants to grow big. So it will start in Greece, it will start locally. We had this discussion during the break, but it has to aim beyond that. Then, if the question has to do with the domains, which is one of the questions we prepared, but you did not ask, Petros, and I have, look, I have a book prepared domains. So, and it was interesting that we saw the picture of the domains from BCG, and I have to say that at least at Athena, we aim a lot to work on health and bio. I think the pharma industry is very well developed in Greece and maybe goes unnoticed at an international level. It's not so easy to work with shipping because shipping does it internally. A lot of innovation and AI is happening internally. And also, I would say, more fundamental things of AI, like decision making and knowledge extraction. These things, I think, can be there. Greece has the talent, it has the resources. One issue, of course, that goes with small country is the cost of resources. So that's something that groups have to take into account.
Thank you. Vasilis Antoniadis raised his hand earlier.
Yes. Thank you for the very interesting discussion. We got perspectives locally from European-based research and, of course, from the US. There is a lot of hype on what's happening in China and more broadly in Asia, both in research but also on the applications. And it's very difficult to decipher what is true, what is hype, etc. To the degree that you can, to give us your perspective, it would be well appreciated. Thank you.
So Vasilis is asking the question about what is happening outside Europe and the US in terms of AI. And may I direct this question to you, Pushmeet, if you have some information about how the global picture, what does the global picture look like in the field?
Yeah, so I think first of all, I think I should say that, see, especially AI can be done by anyone, right? And but the class of AI systems, the large language models that have driven the last sort of phase of interest in AI with the general public, that requires very significant investments, right? So there are very few entities that have the capacity to sort of do that. Mostly sort of in the West, like in the US, like certain tech companies and so on. And now we are seeing certain Chinese entities like DeepSeek and so on, which have invested heavily in building up those type of capacities. So so in terms of that foundational layer, that the diversity of work is certainly sort of lower. But I don't think that that's the only way sort of smaller countries and regional regions can sort of influence AI, in the sense that even if the development of these foundational models happens in these entities, there is a lot of work that needs to be done in localization, in terms of making sure that these models understand and have been trained on things which are important for locals. So I see a lot of work happening in Europe on sort of how do you personalize these models or fine-tune these models on regional languages. Like this is also a very important element in I think in countries like India, where there's a lot of sort of focus on making sure that the regional languages are these models are able to effectively sort of work on those languages. And then there is a lot of work that is happening on actually applications in terms of what is important for that particular region and for that particular economy, whether it's healthcare, whether it's agriculture. Sort of how does democratization of intelligence in the context of that economy be most impactful? So, like healthcare and sort of agriculture are some of the places where I'm seeing a lot of work, especially in developing countries, on the use of AI. But more broadly, I think across the board, I think people are using it for productivity, for sort of productivity services like coding and in law and many other sort of disciplines.
Thank you. Maybe one very, very last question, because we are over time. I don't remember who was the first. I'll take the person in the middle between the two. You, yes, please. Sorry.
Is this on?
Yeah, now.
My name is Konstantin Sabelgas from the Orphic Group. Wanted to pose a question. I think it's more directed to Mr. Emiris and Mr. Mallios, but of course, it's certainly open to any of the panelists to comment on. And it was based on a comment you mentioned, an example you gave earlier, actually, on the route from academia to commercialization. And my question is really, do you feel that there's an important space or a gap, let's say, between getting industry or businesses to enter into the academic part of the research at an earlier stage, perhaps maybe even at the beginning of the research, to facilitate that route? Because I think some cases, academia being a little bit more isolated from real businesses sometimes isn't as effective in developing the technology, maybe as quickly or maybe as relevant to what businesses really need. So my question really is, do you believe that businesses and industry should be involved at a much earlier stage with academia in that? And if that's the route, what's the best way that, or message you could give both academia and industry to working collaboratively at a much earlier stage?
So I actually wanted to ask Ioannis Kevrekidis to answer this question, given your capacity as a program director at DARPA also, that you didn't talk much about that. So maybe you can...
First, I have to have a disclaimer. Anything that I say here is not an opinion of DARPA or anything.
Of course.
I have to say these things. I think I'm going to go on my experience as a rather pure academic. I think that anytime that we had something that was worthy of a real use, industry would find its way to our door. We would get to ask to consult or collaborate. And I think right now, maybe seeing also the way that small businesses, let me maybe say it this way, in the proposals that I get these days for programs, a lot of them, maybe half of them, would have collaborations between a small company or a big company and the university. So I see it happening. How to foster it, which is what you asked, I don't really know. I'm just telling you that I see it happening a lot.
Maybe I can ask also one more answer in this case from either Aristos or Kostas or Ioannis.
I'll answer very briefly. Things are being done. Progress has been made. We try very hard. There's another research center here represented. We try, both Demokritos and Athena. The universities have done a lot of progress, but I think we need the other way around as well. We need the companies to be reactive. We need the companies to be interested. And we would also like to give us examples or to tell us what is lacking. There's a lot of things, not just collaboration. I would say mentorship. But things are improving definitely in Greece and at the European level.
Fantastic.
Can I add something?
Yeah, please, Costa. Yeah.
I like your question. It's a really hard question to answer very directly. I think most corporations, Applied Materials, for example, certainly has relationships practically in every region with universities. Research technical institutions like RTOs, Leti, Fraunhofer, IMEC, just in Europe alone, and then you can multiply that manyfold for the rest of the world. The question, I think, is can you get academia and business to speak the same language? That's really, I think, the key. There's amazing work happening in academia. There's amazing work happening in corporate labs. Some companies have bigger expenditures in R&D than others. But you have to build the bridge, and the bridge is not easy. And so I guess the advice to your question, what advice would you give academia? I think is to start thinking more about business as a potential partner rather than a customer, to get in early and to have these conversations ongoing all the time. The second thing is that also will prompt funding from corporations into academia, which is also very welcome by most universities. One of the biggest issues is intellectual property. And so when you have something that's vital or something that's highly differentiated or competitive in nature, you need to be very mindful about who owns the IP, how is the IP going to be managed, how it's going to be firewalled from the competitors, and so on and so forth. I think if you can address the IP, I think the talent in both corporate and academia, I think, can find a way to communicate, but it has to be very, very intentional. So, like with Athena, for example, we had a very intentional collaboration. It worked out beautifully. I think you can find good models, but it takes two to tango in this.
And I'd like, the last word goes to Eleni.
Well, just to briefly add something, all of what was mentioned is necessary, and I think it's possible through mechanisms that do exist, perhaps not so well organized in Greece, but there is this culture of creating transfer offices in higher education institutions, and then this has to be backed up by seed funding usually from the government or federal authorities in our case, that give specific grants for projects that have collaborators that come from the industry and the academia, together with appropriate mentors and coaches that go together as training when you apply for such a program. All of these mechanisms are necessary so that you can grow from an idea into something that slowly advances the TRL levels that is necessary.
I just want to add, just keep building on this, because I think
our
moderator,
very
are working at a company at this point, right? And you're also
I'm on sabbatical at DeepMind.
You're on sabbatical at a company. Actions like that, I think, are very, very important toward building the bridges. This sort of this kind of fluid collaboration, and sometimes all in, on sabbatical or otherwise. I think those are very, very important ways to both build trust, relationships, and outcomes.
Okay, on this note, I'd like to thank everybody on the panel, first of all. And thank you also, Pushmeet Extra, for taking the time, and thank you to all of you for taking the time as well.
we'll do a very fast switch. We switch now to panel 2 that we invite on the stage. Yes,
Okay.
but of course you can grab some coffee as we.
You're welcome to stay, Pushmeet, or